An advertising agency guarantees its services will increase website traffic by 3.5% compared to each previous week. So as the traffic gets bigger each week, that percentage is going to change. So there's not going to be a constant rate of change, it's going to be an exponential rate of change. The biomass in a lake doubles each year. So that's not a constant rate of change, and we're not going to see plateaus there. We're going to see exponential growth, which is C. Of the following 4 types of savings account plans, which would yield exponential growth? So if we're taking a percentage of the initial savings, that's going to be constant growth. Constant rate of change, the same amount we increase by every year. But if we take a percentage of the current value, that's exponential growth. And this one is just constant rate of change. This problem involves a line and an exponential crossing at 2 points. So, in general, an exponential equation will look like this. It's going to approach 0 and it's going to grow faster than linear would. So if we ever cross a line at exactly 2 points, the line between those 2 points will be above the curve. And that's what's going on in this problem. We have a line, and then we have an exponential that between these 2 points, which are on both lines, we go above the line here, above the line here. They want to know when RS, for RS and RT, RS being on the linear and RT being on the exponential, when is S above T? When is the line above the exponential? And that is in this range here between 1 and 2. The population of squirrels has been doubling every 15 years. So right off the bat, that tells us it's not linear growth because of the word doubling. And if you read the description following exponential growth, is the population increasing by the same amount or by the same percentage? And the same percentage is correct. If it was the same amount, it would be linear. Which of the following describes an exponential relationship? So decreasing by a constant rate, that's linear. For every second increasing by or decreasing by a constant rate is also linear. And this one has so many feet and so many pounds, constant rate. The only one that says for an increase in this decreases by a percentage is A, exponential decay. So the luminosity estimated by the linear equation 3 days after the peak is how much greater than estimated by the exponential. So we plug in D is equal to 3 for both of these. That looks like this. On the linear side of things, we subtract 2.49 and get this answer. On the exponential side of things, we are multiplying by 0.704969 because that is what 0.89 cubed is. This gives us about 7.05 or so. The difference between these two is 0.21 if you subtract them. Photocopy machine is initially loaded with 5,000 sheets of paper. We're copying at a constant rate. After 20 minutes, it has used 30% of the paper, so we take 5,000 and we multiply that by 0.3. We see that 1,500 pages have been used, and that's pages per 20 minutes. So if we divide by 20, we can find that we use 75 pages a minute. This is a linear relationship as it's a constant decline, so I'm going to choose B.